Friends, engineers, architects, HVAC consultants, and students, welcome once again into VK Jain Sir ki MEP classes. Before we go deeper into AC duct systems, let us first see the classification of AC duct. AC ducts are classified based on pressure, velocity, material, shape, insulation, and function. Below is a structured classification useful for HVAC design. Let me tell you that in case of building designs, we are concerned with only low pressure duct, which are working on a static pressure range up to 500 Pascal, and these are used in residential small offices. Medium pressure ducts 500 to 1500 Pascal used in commercial buildings, and high pressure ducts have a static pressure range of above 500 Pascal, and these are deployed in large malls and industrial applications. Friends, the duct can be classified based on materials used. We use several different type of materials as given in column 1. Uh, GI galvanized iron duct is most common, economical, and general used in general HVAC systems. Second category is aluminum duct. It is lightweight, corrosion resistant, and used in clean areas. Stainless steel duct are hygienic, corrosion resistant, and used in hospitals and pharma industry. The PVC duct is chemical resistant and used in labs and corrosive areas. FRP duct, fiberglass reinforced plastic duct, is acid resistant and used in industrial exhaust ducting work. Then comes flexible duct, aluminum foil with insulation. Feature used in short connections for between duct and diffuser. Friends, something more on duct work. First, uninsulated duct are used in return air in conditioned spaces. Externally insulated ducts prevent heat gain and loss. Internally lined ducts are used for noise control and thermal insulation. Pre-insulated duct, that is PIR, oblique PU panels, lightweight and fast installation. Now we are discussing based on function. That means duct classification based on their function. Supply air duct delivers conditioned area into enclosed premises, and return duct returns air to AHU, and normally they go above false ceiling. Friends, this diagram shows the sectional cutout detail of a sheet metal duct. Now it is provided with external insulation as shown in this black, and the white one shows the vapor barrier for moisture protection. The internal lining is for acoustic purpose and thermal insulation as well. The airflow is shown in this blue arrows, blue white arrows in blue. Then the ductwork are provided with the support hangers, this one, and sealant egg joint is shown in this orange color. Friends, we have already seen the duct classification. Let us revise them. Low pressure system for air velocities up to 600 meter per minute, designed for maximum static pressure of 5 centimeter of water. Second, medium pressure system for velocities up to 600 mpm, but designed for maximum static pressure up to 15 centimeter of water gas. High pressure for velocities over 600 meter per minute and static pressure of 15 to 25 centimeter of water gas. In building complexes, we are concerned with low pressure systems only. There is one more thing about ducting, that is aspect ratio. Once the area is known, the duct dimension A and B can be found out easily according to site convenience, keeping the aspect ratio A by B not more than 4. We are now discussing key aspects of duct aspect ratio. Duct, the definition is the ratio of larger side, that is width, to shorter side height in a rectangular duct. Ideal ratio is 1 to 1 square is the most efficient, reducing friction loss and material loss. High aspect ratio impacts ratios above 4 to 1 require more structural reinforcement for avoiding vibration and sagging. Friends, in duct design, the velocity is the controlling factor because this is concerned with the noise level produced by different type of duct. Now, according to space classification of National Building Code, uh, the funnel, these are the sound level in different type of duct systems. Supply air, return air, if it is main duct, so are in branch also. In general, for any duct, the airflow velocity, if it is 180 in case of residence, sound level will be about 40. In apartments, the air velocity is 300 and sound level 40. In offices, it is 60. In library, they have to be kept low sound level. The supply air and return air in main duct and branches are shown in this chart. In studio, the audible level in dB is most important and it is kept something like 30, which is in case of theater and auditorium also. But cinema hall can go little more. Stores bank we can tolerate up to 40. In restaurant it is generally higher. Friends, this chart shows recommended maximum sound level for different type of premises, some of which we have already discussed, but let us take once again. In residence, normal sound level should not exceed 40. In theater, 30, auditorium 30, executive offices 38, general offices it is generally more up to 60. In hospital, it has to be kept low up to 40 level. So is library. In cinema, it is has to be lower. Friends, through this chart, we are discussing duct material. The ducts should be generally fabricated from smooth metal like GI sheet, that is the maximum use, or aluminum in enclosed atmosphere as per Indian standard number 655 metal duct. Gauge should be as given below, which is for low pressure system only. So you can see material GI sheet and aluminum compared and different type of duct formations. Rectangular duct, round duct, and for this diameter is given 75 to 225. Uh, Normally the gauge up to 75 should be 24, which has to be increased to 18 in case of 225 centimeter in case of GI sheet. In case of aluminum sheet, it is 1.8. Similarly for round duct. Friends, thanks for kindly silently observing this presentation on module duct work. Thanks once again.